Okay, so this is a recording of 5 more math problems from the SAT, and they are kind of tricky. Some of them are more tricky than others, but it's all good. I hope that you can understand this video, and if you don't, let me know, and I will make it again or explain it in a different way. So in order to do number 19, or this first one, I hope that you can recognize that it's in the format of the standard form of a quadrilateral. So like this, and we are looking for solutions in the end, and if you remember, solutions is what x equals. Well, this one's a little bit tricky because it's got A's and B's involved. So really, the best way to find the solutions for this, there are 2 main ways. One is you can try to plug all those things into a quadratic formula, and you'd get 2 answers, and then you'd multiply them. That's really messy when it comes to having extra variables in it, and it would take a lot of time. So this is how I would do it to try to make it as fast as possible. It depends on how you learned how to factor, but I would solve it by factoring. So let me show a very, very brief way of factoring that I think is more visual, and it works really nicely for me and my students. And if it doesn't work for you, there are still other ways of explaining this. So this is what I do. When there is a quadrilateral, the first term, you can take the first term and put it right here, 57, x squared, and the last term and put it down in the lower right corner, AB. The reason why this works is because the product of these two will equal the product of those two. So what we're going to do, we're going to ignore the x squared for now, and we would have 57ab. And then if it were normal numbers, we'd say, what are the factors of that 57ab that would add up to get our b, our middle term right here? Well, the nice thing is with this is it shows us is literally 57b plus a. So in one of the boxes is going to go 57b and then an x, and the other one would go a and then an x. And then we look in each of the columns and rows to factor out what's in common. Well, in this column right here, I can see they have a 57 and an x in common. The next column over, they both only have an a in common. And then going the other way, this row right here, 57x squared and ax, only have an x in common, and then these two down here only have a b in common. So my 2 factors are 57x plus a and x plus b. Those are my 2 factors that we could get from here. And then what we do with factors to solve them is we set them equal to 0 and then get the x's, like solve for x. So I would subtract a, subtract b, subtract b. So this side, the b's, x is equal to negative b. And then on this one, we would have 57 equals negative a, or 57x equals negative a. Divide by 57, divide by 57, and our x would be a fraction, negative a over 57. But now this wants us to do the product of those solutions. So here we have one solution, there we have another solution, and we're going to multiply them. So we'd have negative a over 57 multiplied by negative b, and that would be ab over 57, which I could rewrite as 1 over 57 multiplied by AB. Well, this form really works nice because it says over here KAB, where K is a constant. Didn't say it was a nice number, but it would be 1 over 57 because there's the K. So that would be A is our answer for that one. Okay, number 18 is a common one. They have questions, a lot of questions like this on the SAT. They might have them, I should say. But this format is transformation notation for functions. And so if it has the x plus 4, let me just remind you that it would be like, so f of x, I'm going to do x minus h, means it's going to be moving left or right h units, and it's positive 8. So, right, it's going to be opposite. So specifically for this one, the x plus 4 means it's going to move it left 4 from the one that it currently is. So from this one, it wants to go left 4. To help me be able to identify which is which, because I'm literally going to go through these answers and identify which is which, I'm going to focus on some points that I can see on the graph. These 2 points, is it those 2 points? Yeah, this point and then this point look like they're points that exactly fit. So that's the point -7, -2. And this is the point -5, -6. And if I moved it like it says left 4, my new points are going to be -5. So left 4, it's going to be -9, -6. And left 4 would put it over here at -11, -2. Okay, so I'm going to go through my graphs and just look for one that's moved over quite a bit. And I can tell from experience it wouldn't be that one, but it doesn't hurt to go through and do that. So we're going to go to Desmos. So you'll have Desmos available on every question on the test. So use it. So we had 6 over x, 6 over x was one of them. And I can see it does not go to the point -9, -5, 6. That's for sure not there. The next one was 6 over x plus 4. And if you'll notice, this is actually the original graph. Like, right, there's the point. I don't know if you can see this. Let me see if I can get it to go. It doesn't like me when I do this. Oh, there we go. So there's that point well, it's close enough. -5, -6. There it is, -5, -6. That was one of them. So I want the one, I'm going to leave this up here because I want the one that's left, 4 more left from that one. So the next option, and I just have these memorized because I just did this a second ago, was x plus 8. And that looks to me like it moved over 4. And so let's come back to our answers. And sure enough, there it is right there. 6 plus x, 6 over x plus 8. Okay, so that's that because it just moved it left 4 and it matched those points. Okay, this next one is, in order to do number 13 and 16, you have to remember some things about solutions to quadratic, like the graphs of solutions of quadratics. So I'm going to draw a couple really quick, like XY axis, and we're going to talk about the options here. So one way, if we want to have no real solutions, and the next one says exactly 1. So I just want to remind you of what those look like. So first of all, I'm going to go through, we have 2 solutions. So whether it's a smiley face graph or a frowny face graph, that's 2 solutions. Frowny face graph, I should put S. So it would go like that. Same idea, like it would cross the x-axis twice. Then we have 1 solution, exactly 1. This is exactly 1. Would just touch it once. And then, or it could be frowny face. It could also be frowny face coming up and touching it exactly once. Oops, especially if my graph gets up there. Or the last situation is where it just like floats above it. Or if it was frowny face, it would float below it. And it can be on the left or right side. Doesn't matter. This is no real solutions. But that's what we're looking for. So we want this to match that. And when there's exactly 1 solution, let me just show you an example of exactly 1 solution. I like how that just automatically zooms in. Okay, so I'm going to show you what that would look like. If I had x plus 3 squared, which And if you don't remember this one, it's okay. We can go over that later. So x squared plus 6x plus 9. So they're the same graph, right? We're looking like, I don't know if you notice, like they are the exact same graph. But it touches exactly once. And how I can get that if I'm just looking at these numbers, to get from the 6 to the 3, I would just divide by 2. So 6 to 3, I divided by 2. And to get the 9 from there, I just did 3 squared was 9. So they're all related. If we come back to the graph that we have that we were given, we're supposed to graph. We have x squared minus 34x. And then I think it's plus a. I don't remember. I'm just going to say a because it doesn't really matter. We could try to add a slider. And you can kind of see that there is a graph there. Oh, we don't need those up. There is a graph there, but I can't really see it. So I'm going to zoom out. And I'm going to see, oh, man, that's going to have to go up a lot. So we're going to use that same skill that we talked about with the x squared plus 6x plus 9. And I'm going to try this out. If I had x squared minus 34, if I did 34 divided by 2, I get 17. And then to find the a, it would be 17 squared. So let me do 17 squared, maybe if it'll let me push the buttons. So 17 squared is 289. So if I tried the number 289 right here, boom, look at that, it crosses once. So for sure we want it to be, in order for it to float above the graph, it needs to be bigger than 289. So like if I just tried 290, if we zoom in here, oops, zoom in there, you can see it's floating above the graph. So it'd have to be bigger than 289. So we did negative 34 divided by 2, and we got negative 17. And then we did negative 17 squared is 289. So I want C to be great. Oh, they said C, not A. C to be greater than 289 is what I would need. So the number that we're looking for is 289. Did I have it over here? Yeah, 289. Okay, so the next one wants exactly one. We do want it to touch. However, now we have a different equation involved. And yeah, so let's, in fact, before I get involved with it, see how there's the 8? We could still do the same thing. We're going to divide by 2. And we would get x plus 4 squared. So for this one, if I did plus 16, that would mean that this graph itself would float above the x-axis, but we want it in relationship to this, so we're going to have to do some wiggling. But let's go back and graph it. So negative y equals negative 1.5. And it zoomed in. Okay, delete all. Okay, so negative... Oh, wait, I need to do y equals negative 1.5. And then the other graph was x squared plus 8x. And then it was plus a. I think it was a in this one. Add a slider. And if I slide it, I can see like I'm getting there, right? But I already knew that I was supposed to do, I wanted to be at, I'm going to see what happens when I had my 16 there, right? Because we did that 8 divided by 2, and it crosses the x-axis, but we want it to touch the line right here. So we're going to want it to go down. And how much do we want it to go down by? I can't really draw on this, but I can see to get from, it's going to go down 1.5, right? So we want to do our 16 minus 1.5. So let's just check. If I had, I'm going to replace the A with 16 minus 1.5. Ha! And it crosses exactly. Boom, just like that. So 16 minus 1.5 is going to be our answer. So we wanted 16 minus 1.5, which would be 14.5. So exactly one thing would be, of one solution would be 14.5. So it would be the x squared plus 8x plus 14.5. Because 14.5 is 16 minus 1.5. Okay, last one of these is a population of a city. It increased by 7% from 2015. So here's 2015. It was 100%. And then it increased by 7%. So then in 2016, it would be 107%, right? And all we would have to do is change this back into a decimal, so 1.07, and that would be the times, it says K times, the in population, so our answer is 1.07. All right, hope this helped.